Yes, hello everybody. Thanks, Regina. Welcome to the 9th short online course in the EUMETSAT short course series, and to the first short course in 2021. I'm very pleased to see so many people joining in. First of all, I would like to warmly welcome the experts for today, Stefan Kote and Danny Parsons. And also my colleagues from the tech support, Regina, who you just heard, and Madalena, who are helping to facilitate this course in the background. So if you have any technical issues, then please send a chat message to support directly. This will land with Regina, and she would do all she can to help you. If you have any questions on the content that is presented here during this course, which I hope, then please go to slido.com. You can also download the app to your smartphone and enter the code #EUMSC9. This is where we'll follow the questions and we will answer them either directly there or at the end of each presentation here in the short course. Okay, before we start, I would like to tell you a few words about who EUMETSAT is. Regina, quick question. Can you see my slides? Because I can't get them moving. No.
Yes.
Okay, yeah. Okay, so no. Sorry. First of all, I'd like to do some advertisement for upcoming short courses. So in 2 weeks from today, there will be a short course on applications of EUMETSAT to analyze and validate satellite-based climate time series with the same people, but with slightly changed roles. This is a nice follow-on to the course we are having today. So today we'll talk about how to use an R toolbox to analyze spatial time series. And in 2 weeks' time, we're going to talk about a tool that is useful to work with station data and to compare station and spatial data. On 18th February, there's going to be a very interesting short course on the ozone hole. And in March, we have a short course on how to build a case study demo session. And there is more to come. So watch out for more announcements. This series of short courses will continue. And there will be short courses throughout the rest of the year. So watch out at our training pages or at the EUMETSAT Twitter feeds, and you'll learn more. So EUMETSAT short courses. Who is EUMETSAT? EUMETSAT is an intergovernmental organization. At the moment, we have 13 European member states, and our tasks are to develop, maintain, and exploit European systems for meteorological satellites, while taking into account, as far as possible, the recommendations of the World Meteorological Organization. And in addition, we also contribute to operational climate monitoring and the detection of global climatic changes. And we're also part of the European Commission's Copernicus Earth Observation Program. Exploiting European satellites, that also means helping users and supporting users in using the data these satellites provide to us. And so this is what we are doing today, is actually part of fulfilling our mandate. So we are operating quite a few satellites at the moment, and here is an overview on which satellites are currently in orbit. The latest that we have launched is Sentinel-6, an ocean altimetry satellite, which was launched in November last year, and the next one to be launched is going to be METEOSAT 3rd generation, the first of a series of satellites, and the launch for this one is planned for next year, 2022. Doing satellite business in a way EUMETSAT does it is a long-term task. So we're involved from the very beginning of gathering needs and developing a satellite until launching it and operating it. So we're working on long timescales, which you can see here. This means planning ahead quite far. But this also means looking back. What did satellites, what were satellites able to gather? Which information can they provide us about the past? And in doing our work, that we hope that we can support scientists in analyzing connections in the environment, in our climate. And this is what EUMETSAT is doing. So we are providing climate data records together with the so-called satellite application facilities. And the tool we hear about today is specifically designed to analyze long-term spatial time series of data. So a few words about the SAFs, because I was mentioning them very briefly. At EUMETSAT, we are not working alone in Darmstadt, but we have a big network of so-called satellite application facilities, and these are dedicated centers of excellence in processing satellite data for different topics. So here we collaborate a lot with entities in our member states, and each SAF is a consortium of entities from different EUMETSAT member states, which makes working within a SAF and working with SAFs so interesting and so exciting, I think. And the tool we're going to hear about today was developed within the CMSAF and was originally specifically developed to work with CMSAF data, but it is applicable to more and more spatial climate data records. So here's a short course program for today. This is currently the welcome and introduction session, which will be finished very soon. And then I will hand over to Stefan Kote from DWD. DWD is the lead of the CMSAF, and he will introduce you to the toolbox and its functionalities. And after that, there is time for a few questions before we leave you off to play with the toolbox by yourself. We give you about an hour time to work with that and to get the first impression on this tool. And then at 2 UTC, 14 UTC, we invite you to come back to a question and answer session. So you will have the chance to ask your questions there, or put them on Slido, and we'll go through them if you have any immediate questions before we wrap up the short course for today. And but this is not the end, because if you wish, you can join us next Monday for a question and a feedback session. The links to it you find on the Moodle page. Can somebody help me out with the time? I'm sorry, I forgot to mention it here on the page, but I think it's also 12 o'clock UTC. Can somebody confirm for my colleagues, please?
Yes, that's the time.
Okay, thank you. So next Monday, January 25th at 12 UTC, you're invited to come back for a feedback session, and we hope that in the meanwhile you may have had some time to play further with the toolbox and explore it further, and yeah, to share with us what you were able to produce in the meantime. But now it's time to introduce our experts for today. So I welcome Stefan Kote, who is actually the developer of the CMSAF toolbox, and Danny Parsons, who is an expert on EUMETSAT. But because these two have collaborated so closely to make to build interfaces between these tools, Danny knows the software very well, and he will be available in the background to help answer your questions on Slido, and to also guide you through the exercises and through the hands-on session. So I will stop my screen share here and hand over to Stefan.
Okay. Hello, everyone. Hi, it's me, Steffen Gothe, from the Satellite Application Facility on Climate Monitoring, the EUMETSAT. So today I present one way to work with satellite-based climate data using the EUMETSAT toolbox. I will start with a brief overview presentation followed by a live demonstration. So in the end of the day, I hope you should know what the toolbox is, what you can do with it, how you apply it, and if it might be useful for your work. So please ask questions via Slido at any time. I think Christina and Danny will monitor them and bring up the most important ones. And in addition, we try to answer all questions in the course of the day. So, but first of all, I tried to put into one slide what the EUMETSAT is. So we develop, generate, archive, and distribute satellite-derived products in connection with the energy and water cycle to monitor, understand, and adapt to climate variability and climate change. So that means we produce long-term climate data records of parameters such as cloud coverage, cloud properties, surface radiation, sunshine duration, or evaporation and precipitation. At first glance, that seems to be a huge amount of data in a strange format, which can only be processed by experts. But as a second look, it is a bunch of possibilities and a real treasure of knowledge, which is much easier to raise than you might think. So don't be afraid, be curious. So that's why the EUMETSAT provides the EUMETSAT toolbox. It should be an easy to use tool, which simplifies the start with these kind of data. So the R in the EUMETSAT toolbox stand for the scientific programming language R, which is widely used in geodata. Nevertheless, the use of the toolbox requires no scripting or R experience. So why do we need a toolbox? Together with EUMETSAT, the EUMETSAT held training workshops on regular basis all over the world. So my first workshop as a trainer was this one here in 2015 in South Africa. Greetings to Samantha. For this workshop, we wanted to increase the efficiency and reduce the time spent on software installation and explanation to have more time playing with the data. That's why we developed the EUMETSAT toolbox to replace the climate data operators, CDO, and a collection of R scripts. And this tool allows an easy handling of EUMETSAT NetCDF data. So you have one software for data preparation, data analysis, and data visualization. Therefore, the original target audience were beginner with satellite-based climate data. But due to a steadily increasing number of functionalities, it might also be useful for climatologists from national meteorological and hydrological services, research institutes, or similar. Like mentioned, the toolbox requires no R or scripting experience, but also people who know R can easily script their jobs using the EUMETSAT packages. And maybe most important, users who are interested in EUMETSAT data or in general in climate data in NetCDF format. The EUMETSAT toolbox is an R-based graphical user interface to work with climate data records in NetCDF format. So the toolbox is part of the EUMETSAT R package that's in free library for R, which is available via the CRAN repository. You just type in R run toolbox to start the toolbox. And the EUMETSAT toolbox is now a graphical interface to the functionalities of the EUMETSAT Vis and the EUMETSAT Ops R packages. So the EUMETSAT Vis package contains functionalities for visualization, and the EUMETSAT Ops R package contains operators for analysis and manipulation of NetCDF data. The CMSFR toolbox originally was developed to work with just CMSF climate data in netcdf format, but in principle, each netcdf file with time, longitude, and latitude dimensions should work with the toolbox. And the handling of other data than CMSF will even be improved in the upcoming version. The toolbox consists of 3 main steps. So the first one, the prepare step, helps you to prepare your ordered CMSF data. That means extracting, choose time and region, and merging all data into one file. The analyze step is a part where the magic happens. So here you can do all the analyses and manipulations of netcdf climate data, which are needed for your projects and applications. And in the end, users want to visualize their results. And for this, the visualize step offers a lot of options to adapt each figure to your needs. The toolbox is a graphical interface for several operators. And when I'm talking of an operator, I'm meaning functions such as monthly means or seasonal sums. And if you click in the toolbox on the monthly means, for example, this applies the CMSF operator monmean. So each operator can be applied separately in the R console. That has the advantage that it is scriptable and offers in general more options. And like you can see in this example of the monthly mean, the monmean operator of the CMSF ops package, it shows that it is how it is applied in the R console, and it is in general quite easy where you give a variable name, an in file name, and an out file name. That's a general structure. The next slides will show some of the highlights of the toolbox, and maybe this makes you even more curious to play yourself with the data. With the release of the upcoming update of the toolbox, there will be more than 100 operators for the analysis of climate data. You can download your results in multiple file formats. For instance, you can download your results in KML format and visualize them in Google Earth, or download a GeoTIFF and use your favorite GIS tool to make nice plots. The upcoming version will also include the option to compare your data with other satellite or station data. So it's just choose 2 data files and click on the kind of plots you would like to see. That's it. There are many options to visualize your results in a nice way, I think. And there's also a quite simple solution to create climate analysis plots with just a few clicks. So like you can see in this example, 2020 was the 3rd sunniest year in Germany since the beginning of our Sarah 2.1 data record in 1983. And it was even the sunniest year in Europe. As the CMSFR toolbox is using R Shiny, it's relatively simple to publish the toolbox as an application on a remote server for hosted processing. Currently, we are working on such a web-based service for our users. So this could mean you don't have to download all the data. Instead, you do your analysis online and download only the results. And if you need help using the toolbox, have a look at our manuals, YouTube videos, toolbox paper, the question and answer document, cheat sheets, flyer, etc. All this stuff is hosted on the CMSF our toolbox website. Or if there are some questions which cannot be answered by this material, just write an email to our user help desk. And the CMSFR toolbox is a software from scientists for scientists and in continuously development. So your feedback on bugs, missing features, possible workflow improvements, or even code improvements is always welcome. So coming up next is a live demonstration of the toolbox, followed by a brief introduction to possible hands-on exercises. So are there any urgent questions so far? I don't hear.
I think there is nothing urgent at the moment. Somebody is asking for the link to the latest version of the R toolbox, but maybe we can do that afterwards and after your presentation, and you can share the link then in the chat box if that works for you, Stefan.
It's quite easy. If you Google Cran EUMETSAT, you will get to the page. Okay, then let's go on and let's play with the toolbox. So like I said, to start the toolbox, you just use the run toolbox command. That's the only thing you have to do really in R. So you can download the EUMETSAT climate data for free via our web user interface. So details are on the Moodle site, on the EUMETSAT website, or via wui.cemsaf.eu. And the ordering process is quite easy and intuitive. And in the end, you will get an email with a download link. You will get your data then in the form of a tar file. So this tar file contains one .netcdf file for each time step. So for daily long-term climate data, this could easily be several 10,000s of files. And for more details on tar files, please have a look into the cheat sheet #1 on the course website. And for this, the prepare step will help you to convert this tar file into one ready-to-use .netcdf file. So we're starting the prepare step, and first we choose a tar file. For this, I ordered long-term Sarah 2.1 surface incoming shortwave radiation data from 1983 to 2020. And you will get, when you do this order, you will get 4 tar files. The order comes in 4 tar files. And here comes the first tip. If you order comes in several single tar files, just rename them to the same 5-digit ordering number, and the files will be handled as one. Make it a little larger. So you can here see I got the 41286 and renamed all other tar files with the same 5-digit ordering number, and now all files are handled as one. So you can choose one of the 4, it doesn't matter which one.
Sorry for interrupting, Stefan. Sorry for interrupting. We have some questions here from people are asking if you have Mac version. If you go to the questions and answers, you can read them as well. Perhaps you can quickly answer them.
Questions out there?
Okay, we'll try to answer the questions here now, but for further questions, it would be good if people could use Slido for their questions. It's Slido.com.
Yeah, I have the Mac version. That's why when I'm opening files, I'm asked if I want to save and replace. That's a little confusing, but it's only a Mac and Linux issue. It doesn't matter. You don't worry about this. Where did we stop? So now you can see the included time period in the data. So here you have the option to restrict the time period. That, for example, offers the option you download once the whole time period, and just use the period you are interested in for a specific application. So afterward, the data for the chosen period will be extracted. And I want to mention the timestamp of monthly data is usually the first of each month. So here you can see these data are monthly data from January 83 to December 2020. Now I click on Untar and Undip, and the data are now, whoops. Now you can see they are untarred here in this data folder. You can see all the more than 460 files of which were included in the 4 tar files. Now you can choose the variable and the region of interest. So some climate data records include more than one variable. Like here, the SARA 2.1 SIS data includes the surface incoming shortwave radiation, as well as the surface incoming shortwave clear sky radiation. So we are choosing the SIS variable. You can also restrict the area if you want to, but it doesn't matter. And click on Create Output File. And finally, all extracted netcdf files will be merged into one final netcdf file, which will be written into your output folder. You can also have a look again quickly. Here's your output folder. Now you have one file including all the 450 something time steps. Yeah, I think the next version of the toolbox will also include the option to choose directly a bunch of netcdf file. And this will allow the usage of other SAF or C3S climate data. And there will, in addition, there will be an option for temporal aggregation in the prepare step, which might be useful to reduce the amount of data. So now let's analyze the just produced file. So this is the main part of the CMSAF toolbox. Here you can do your calculations, analyses, and manipulations. First of all, I will briefly explain what you are seeing. So usually there will be just one variable, like here in this case, because we just chose SIS. To make it easier to find a specific operator, I decided to group them into different categories. You can see all operator groups, groups of operator. And for each operator group, you will get a selection of operators. Like for the monthly, you can see here's a bunch of monthly operators, which can be applied on. So the operator names should be easy to understand, I hope. That's why these names might differ a little from the used operators in the CMSAF ops and CMSAF with R packages. The selection of an output format is in most cases not necessary, but let's see, for an example, if we use, for example, the select data at multiple points, you can also select CSV as an output format. And like you can see, for some operators, you will get additional options, like here the input of latitude and longitude. But mainly these options are limited to a minimum to make the usage of the toolbox easier. More options might be available for the R package operators. So let's try an example using the just prepared surface radiation data. This short file name, short file information shows you most important metadata of such a file, for example, the longitude, the latitude, and the time dimension. And one of the first tasks for our training workshop participants is usually to plot a climatology of their country. So going to the operator group temporal operators and choose the all-time means. So afterwards, just click on Apply Operator. Whoa. For effect. I don't know the English word. Okay. the result will be written into a netcdf file in your output folder and displayed in the visualization panel. So let's have a look. Here's your output folder. Here you have now I just created two. Here you see the just created temporal mean of all the data which are included in this file. So I think the visualization panel, you should play around with all these options and discover the possibilities on your own. For example, I can show you how to plot a region, for example. The data I downloaded here include the data for Uganda, and you can simply plot just the data for this country. You can adjust the color bars and labels and many more. Let's try to plot a location. Okay, that's the capital of Uganda, I think. And in the end, you can download this figure as PNG, JPEG, or PDF, or you can download the data in KML or GeoTIFF format. So let's have a look at another quick example using the same data file. So we're going back and again to analyze. So let's have a look at monthly anomalies of SIS for one specific location. So we're going on analyze again. First, we want to create monthly anomalies. So this is the operator group monthly statistics, and here you have the operator monthly anomalies. But before hitting the apply operator button, check the box, apply another operator afterwards. It's also here a Mac issue. In Windows, it looks a little bit nicer with a tick. Now you can click on apply operator. And now the output file, including the monthly anomalies, will be created. This is this file here, which you will find in the output folder. So secondly, we remove this tick from the apply another operator and go to the operator group selection. Select data at a given point. So now we can give the longitude and latitude. Let's do again for compiler. Apply. So you get now, so what we now see is the time series of monthly anomalies of surface downwelling shortwave radiation from January 1983 to December 2020 for the chosen location, so in this case for Kampala. So that's a lot of data, I think. So you can also click on the option Analyze Time Series to get some statistical plots, which might be easier to give you some information back. And in the end, of course, you can again download the data in form, the figure in form of PNG, JPEG, or PDF, or you can download the data as a CSV file. Okay, that's what I wanted to show you in this live demonstration, and I'm happy that nearly everything worked fine. Are there any more questions before we go on?
Yes, Stefan, there are some questions on Slido. Regina, could you put them up maybe here so everybody can see them?
Okay, one moment, please.
Okay, thanks. So first question was on the link. If somebody, Stefan, if you could provide the link to the latest version 3.00, but I suggest we do that once we are done with the questions here. Afterwards, so you can maybe.
I replied with that link as well.
Okay, thank you. So that's done already. Thanks a lot.
And if you're using RStudio, you just click on install, type CMSAF, and then you will get the package. You don't need any links.
Okay. Next question is, can the toolbox be used for statistical downscaling of regional climate data, I assume?
You can remap. So there are some functions for remapping, but I'm not sure if that is statistical downscaling. What do you mean?
Yeah, so whoever asked that question, if you want to, if you want to raise your question here, and I can give you the microphone so you can articulate. I see Samuel has a raised hand. I try to open your microphone here. Don't see the mic option. Regina, can you help me out here, please? I can't find how to give Samuel the floor. I can only open the chat.
Now, Samuel?
Yeah. Samuel, can you try to speak? You need to unmute yourself now, but you can do that by clicking on the microphone. Yes, now you can talk.
Hello, I'm very grateful for this opportunity. I'm really happy for this particular development. And I think I was the one who was requesting whether we have the Mac version, and I think it was been answered already. So I'm okay with that. Thank you.
Okay, thanks. Okay, if I just may ask the one who asked the downscaling question to raise their hand and the other ones to lower their hands, please, so that I can see who that was. Yeah, Regina, can you give the microphone to Paul? Yeah, Paul, you can now unmute yourself and speak.
Yeah, thank you. Thank you very much. I was actually the one that asked the question, can this toolbox be used for statistical downscaling of regional climate model outputs? Maybe, for example, does it mean that it only work with data set we downloaded from because there's a particular link where we can download the data set? Like, can we use it for downscaling codex experiments? Is it possible?
Well, I guess it depends what kind of downscaling exercises you would like to do. Generally, you can use all NetCDF data with latitude, longitude, and time information with it. But if you have more specific questions, I would like to postpone that maybe to the offline phase. We can still chat amongst each other to see how we can best help you.
Okay, I'm also the one that asked, is it possible to visualize maybe spatial plot or maybe wind and rainfall on the same plot? Like maybe we want to see how when we are plotting your wind direction, and then you see how that's actually affected precipitation maybe over a period of time. Is it possible to make that kind of plot with the toolbox?
I could barely hear you. Maybe I'm having sound issues, but I was having difficulties to understand what you just said.
Okay, for example, now maybe I want to make a plot of maybe aerosol optical depth, and then for a wind speed at a particular level. Can I make the plot of the two elements on the same plot? Do you understand me now? Like making
yes, I understood.
element on the same plot. Yeah. Like I think.
Yes.
Is it possible with toolbox?
Stefan, would you like to reply to that question?
So as I understand, two plots side by side, or what?
No, it's on the same plot. Like when you're doing a time series, because you can make a time series plot, like a spatial plot of the two elements on the same plot, like a climatological plot now, for example.
No, I don't think that this is possible at the moment.
Okay, thank you very much.
Okay, then the next question is it possible to use any kind of NetCDF data, like ECMWF reanalysis data, for example?
Like I said, in general, if the data are in NetCDF format and contains a time, longitude, and latitude dimension, it should work. We will improve the usage of especially ECMWF on all data in the upcoming version, because at the moment you need one merged, one single NetCDF file, which you cannot at the moment prepare with a prepare step, but you will be able in the upcoming version. I hope this will be available on the next 3 weeks or so.
Okay, thank you. Next question is, this is a question we just had. Can we visualize two elements? That was Paul's question. I think that's done. Can I download satellite data using the EUMETSAT toolbox?
No. You have to do this with our web user interface. But it's easy, I would say. I know a lot of other ordering tools, and I would definitely say we have one of the best.
Okay, the next question is, can we have our own subregions shapefile imported, then use it for analysis?
At the moment, not for analysis, just for visualization. But you can import your own shapefiles for visualization. Yeah.
Okay, very good. Comparison with ground data is great. Can you demonstrate an example now? Is there a specific format that CSV needs to be? I don't want to be rude here, but this is exactly what we're gonna show you in 2 weeks' time in the EUMETSAT course. I would like to postpone that question to in 2 weeks' time, and I hope to see whoever asked that question that you have time to join in. But even if not, the material will be provided after the course. I hope that's okay. Next question here is, do you have a Mac version?
Yes, like I said, I have. That's why some menus look a little different, but the behavior is the same.
Yeah, and then we continue. Is it possible to use the EMSFR toolbox on Windows?
Yes, it is. It's usable on all platforms, I know. So on Linux, Mac, and Windows.
Okay, next question is identical, so we can go to the next. This looks like an installation problem. Let's please deal with that offline. So after this,
you can go to the question and answer document, which is on the R-Toolbox website, and there's specifically this question answer. Problem.
What's happening?
There's been some discussion on that. questions. I don't know if you can show the replies, Christine.
I don't know. I don't have the control on the slider interfaces.
I thought that was you. Yeah, but yeah, maybe that Stefan, you could try to follow up on that offline. I've tried to answer any questions about installation and things, but there are a few other technical questions coming up.
Yep. Okay. I think we can also skip the next question because this was answered already. Would CMSF Toolbox work with any NetCDF file? We've discussed that. Hi, I was just wondering if CMSF climatic data is available for everywhere across the globe or only for specific regions?
Do you want to answer or?
Well, yes, I can. Well, today the subject is on the toolbox, but it's of course okay also to ask these kind of questions. Yes, there are CMSF climate data who are available globally. Some are available for the EUMETSAT full disk, and you can find out more if you go to the CMSF webpage, and I can post a link into the chat here. Next question is, can I have a link to install the toolbox? I think I can answer that quickly. If you go to the Moodle page of this course, and I can also post the link to this course once more, there you will find all kinds of links that you need to install the toolbox on your computer. The next question is an interesting one. How do I build my own operators, like an index?
I think.
Okay.
It's not easy to.
Yeah. Is there an option to export the prepared data as a geo into further analysis in other programs, for example, Python?
You can only export from the visualization step, but then you get data and you can do further analysis in whatever program you like. Yeah, but the export function is implemented in the visualization step.
Yeah.
So
but I think if people are used to work with Python, they should also be able to work with the NetCDF data directly in Python. So
yeah, and it's also quite simple to apply all operators of the CMSF package ops package in Python. So they are quite easy to use wrapper, where you can use CMSF ops package functions in Python.
And we are also working on that on the EUMETSAT side, and in the not too far future, we will be able to provide you with some Jupyter notebooks that will be able to do that. Sorry, I was muted. I tried to order CMSF data from the CMSF site. Where's the question gone? Oh, okay. I just continue with what I see now. Can the toolbox be applied to data from satellites other than EUMETSAT like MODIS data? The answer is again, as long as it is in NetCDF format with the latitude, longitude information and time information, yes, you can. I have tried to upload a NetCDF file and I got this message, wrong file format, please choose tar file to continue. Should I use tar format?
In the prepare step, only tar format is allowed at the moment, but you can wait for the next version. Then you also have the option to use NetCDF files in the prepare step to merge them.
Am I right that they could just go straight to the analyze step with a NetCDF file?
That's right. You can go straight to analyze, visualize, and then you can choose a NetCDF file directly.
Okay, now here's this question again. I tried to order some data from CMSF site. I selected a product and then I selected a specific region. But when I ordered it, all the final regional selections was downloaded. Is it a bug?
We had a similar bug. This could happen if you logged in at the wrong time. So between some steps of the ordering process, but I thought it is fixed. Maybe the user might be confused because in the end, when you click on submit order or something, you will see the size of the whole data set and not just for the region you selected. When you get your final download link, you will get the size of the data. Maybe that might be confusing if you see a huge amount of data.
Okay, next question is, I assume that is where can I get tar data? I assume that refers to CMSAF data, and you can order them via the CMSAF webpage. And again, the links you find on the Moodle page. Are irregular time series supported, e.g. missing dates, pixels?
You should try and tell me. I'm not sure.
What is the difference between CMSAF to RInstead? I assume this means CMSAF. What's the difference between the CMSAF R toolbox to RInstead? Stefan and Danny, who would like to reply?
Yes, I gave a quick reply there just to say, yeah, so RInstead is a separate software, but also based on R, which will be introduced in the next course. And the main use of RInstead in this context would be for analyzing station data and to compare station data with satellite data at the same locations.
Okay, the next question is, I was trying to understand it. Can I use satellite data, for example, EUMETSAT products at all as netcdf from archive? Ooh, I can't see the question. Something happened. Can somebody? Yeah, thank you. Can I use satellite data, for example, EUMETSAT products at all as netcdf from archive in different format, already organized in text file, longitude, latitude, value? Any possibilities to analyze them with toolbox and or compare with CMSAF data like ground data? So I think the question is if one can compare EUMETSAT satellite data with station data. This is how I interpret this question.
There is a quite simple option already included. So this involves RInstead. You can export station data from RInstead and use them as input for the toolbox and get a quite simple comparison. Or you just wait for the next update in a few weeks where we improved this functionality.
There is an error message. Somebody has tried to load a shapefile to visualize, but some message appeared. I don't know, Stefan, can you answer it now, or would you like to go back to it on Slido? I assume that's always a bit tricky to analyze error messages here.
Yeah, maybe we discuss offline, but it looks like maybe the data are not included in the, or there's no overlap of data and the shapefile. Not sure about this.
Okay, so we'll deal with that offline. Next question, a very interesting one, I like it very much, is it possible to download CMSAF data like ERA 5 data using ECMWF API?
I don't know. I think the only way to order CMSAF data is the web user interface at the moment. Oh.
Yes. Yeah, official CMSAF data. yes, it's at the moment not available via an API.
There will
Is
be
the data
CMs of data available in the Copernicus climate. Maybe there's an API. Yeah.
data that are provided via the Copernicus Climate Data Store will be accessible via an API, yes. Is the data free? The answer is as simple as yes, the data is free. Any data gap filling algorithm is available or can be used to do that.
At the moment, no. But if you have some proposals, let me know how to do it.
Okay. For the moment, I don't see any further questions. So I think we can go ahead with the hands-on phase. Stefan, I don't know. Yes.
You might want to look briefly in the Q&A in Zoom on the bottom. There are 11 questions there.
Sure.
Do you see that?
Okay. I think we've answered most of them as far as I can see. Yes, I think most of them have been answered. I will have a look and through right after this and try to answer as best as I can or forward them. But I also want to go to the hands-on phase now. Stefan, would you like to introduce the hands-on exercises session? Stefan, at least I cannot hear you.
Sorry, I was talking to myself. So the plan for this webinar was to present the CMs of our toolbox to you and then give you some time to play with the data and the software or even doing a small project. And I would like to give you some inspiration on how to start. So now you can explore the CMs of our toolbox on your own. Maybe you could even define a little project for this. And the first step will be to download CMs of data. The example data of the live demonstration and the of the tutorial video are provided for download via the course website. But we encourage you to order your own data via the CMs of web user interface, which you can see here. So you can post your questions on Slido, like we said, and afterwards you can upload your results to our CMs of Padlet site. There we can discuss and comment on results. You can send bugs or possible improvements to the training email. And we would like to discuss with you on your results on the Monday. Oh. Okay. Sunshine duration in your country. For this, you have to download monthly SARA 2.1 sunshine duration data from 1983 to 2015. Make a long-term mean and then visualize the results. So for this, you can have a look at the cheat sheet number 1 and 2. Or you can ask you, is there a trend in surface radiation for your city, maybe? So for this, you have to download monthly SARA data. You can choose whatever parameter you want. I said here SIS data. In addition, you download monthly SIS ICDR data. And here's a quick side note. CMSAF provides so-called TCDR, so thematic climate data records, and ICDR, interim climate data record data. So very short, the TCDR production involves information from long-term time series of satellite measurements and is updated every 3 to 5 years, while an ICDR uses just the latest satellite data and comes with a latency of a few days after measurement. So, but the combination of these two is very good suited for climate monitoring. So after you downloaded the data, you combine the data into one .NET-CDF file. Like I said, you rename the tar files and go to the prepare step. Then you can create monthly anomalies, select a location by choosing coordinates, and visualize the results maybe by using also the analyze time series option. And for this, you can have a look into the cheat sheet number 1 and 3. And a little more sophisticated is the is to find the answer for, was the sunshine duration in December 2020 normal for your country? So for this, again, download monthly SARA sunshine duration data from 1983 to 2017, and then download the monthly sunshine duration ICDR data just for December 2020. Next step, you have to combine the SARA data into one .NET-CDF file, not the ICDR data, and create the monthly anomaly for December 2020 with reference to 1983 to 2017 and visualize the results for your country. You can have a look into the provided tutorial video to how you can do this. And the last proposal for a small project might be, how was the sunshine duration in 2020 for your country? So these kind of figures we're usually sending out on Twitter every month. So, and for this you have to download daily SARA data, sunshine duration data from 1983 to 2017, and the daily ICDR data from 2018 to 2020, but be aware that daily data means a lot of data, or could mean a lot of data. So you make sure that you restrict the area. Combine the data into one .NET-CDF file, create a field mean and anomaly plot using the climate analysis operator, and have a look at the provided toolbox video to see how you can do this. So now, ladies and gentlemen, start your toolbox and I think have fun.
Yeah, thank you. Thank you very much, Steffen. So you now have time to play with the toolbox a little bit and to explore it on your own. And we meet back here in 1 hour from now at 2 o'clock UTC for immediate questions. And if you wish, you can join us here next Monday at 12 UTC for a more detailed feedback session once you had time to play with the toolbox a bit more. And I don't know, Regina, do we? Yes, we have it. So only for those who will not be able to join us later, I would like to ask you to go to Slido and to the poll on Slido and to give us your feedback about this course. This is very helpful for us in order to improve our short courses in the future. Thanks for doing that. And now I'd say have fun playing with the toolbox. Slido will continue to be available. You can post your questions there. And Steffen, Danny, and myself will do our best to help you. We will be on Slido for the next hour, but we will also have a look on Slido every now and then until next Monday. So even if you cannot join us later on today, but would like to join us next Monday and have questions throughout that time while working on the toolbox, don't hesitate and post your questions there. And now I stop talking and wish you lots of fun playing with the toolbox. Talk to you in about an hour in this Zoom room.